So hello everyone and welcome to Best Practices for Reducing the Cost of Current Products. My name is Matt Roy and I am an expert services consultant at Apriori, and I am joined today by my colleague Amanda Bly, whom you may have heard of earlier in the day, who is our principal research scientist. So I mentioned that this is in regards of best practices for reducing the cost of current products. And more specifically, I want to focus on my title here, shortening time to value, and within that VAVE best practices. On our agenda today, what we're going to focus on is a brief introduction about myself as well as the topic. We're going to dig into target costs versus estimated costs, go through a couple topics on insightful reporting, dig into a little bit into machine selection and how that has an impact on cost, look at some manufacturing alternatives that could lend themselves nicely to some cost reduction efforts. And then at the end, what we're going to do is I have a pre-recorded demo that I'm going to narrate over that walks through each one of those previously mentioned techniques for cost reduction in a logical order that an engineer might take. So an introduction, a little bit about myself. I've been with Apriori since March of 2018, and during my tenure, I've had the pleasure of working with numerous clients ranging in industries from automotive to aerospace to consumer durables. And throughout that work with our clients, I've been able to implement a number of prescribed Apriori workflows, custom reports, and custom logic, as well as really general mentoring and user enablement to make sure that the folks that are using our tool are getting the most value out of it and easily. My background is in mechanical engineering. I'm pretty into sports. The two sports that I like the most are probably football, do a lot of fantasy football, and golf. And then above and beyond that, I'm a very strong advocate for renewable energy and overall sustainability moving forward. So introducing the topic today. So like I said at the beginning, we're going to be talking about VAVE best practices. But before we do that, I wanted to spend a moment and really talk through what VAVE means for those who may not be otherwise aware. VAVE is an acronym for value analysis / value engineering, and it's where engineering efforts are placed on components to reduce cost and improve overall performance. Now, looking at the graph that I currently have on my screen, you can see that the majority of cost is really fixed thereafter the design process. Now, with that in mind, and everything else that's going on in the world currently, companies are really being forced to postpone their NPI in lieu of more aggressive cost-saving measures on existing products. Oftentimes, it's pretty difficult to understand where cost can be driven out of the product, and as well as the ability to prioritize what your cost reduction efforts are based on options and their cost impact. And what this leads to is missed opportunity. Concerning improved margins and costs if you're unsure on how to identify them. And so what this does is it gives us and presents to us a really unique opportunity to be able to explore engineering tools much like CAD or finite element analysis to contextualize the cost of manufacturing a particular component. And Apriori is a very powerful tool to be able to facilitate this manufacturing cost analysis and really to help validate any subsequent cost reduction efforts you might have. So what I would ask for you guys to do today is just think critically about the concepts that we're going to be discussing and how they may be applied to your particular business processes. And hopefully by the end of the presentation, we'll be able to apply some of these techniques that I'll show you to identify previously unknown cost reduction opportunities. And ultimately, what we're looking to do is increase efficiency and quality while decreasing our overall cost. How Apriori works. I want to spend a couple minutes talking through how Apriori works at a very high level for those that may be otherwise unaware. What we first do is we take our 3D geometry from a CAD file, we load it into Apriori, and from there, we're able to disambiguate individual geometric artifacts into GCDs or geometric cost drivers. Once we have those geometric cost drivers, we run those pieces of geometry against manufacturing simulations in our cost models at the back end of our digital factories. And our output from that analysis is cycle time. So we get a cycle time for every single feature on the part. And then what we do is we roll that cycle time up to the process level. And from there, we impose accounting logic and data against that time to arrive at a cost. The accounting logic can be driven from the US, or it can be driven from other geographical regions around the world to better represent your particular manufacturing environment. The first topic that I want to discuss is establishing visibility into estimated cost and target cost. Everything that falls in this presentation is going to be pretty important to us, but this analysis of looking into estimated cost versus target cost is where we need to start, because it gives us an idea of which components that we need to look at deeper to understand if there are potentials to reduce our cost based on what our target cost is. So in design, and specifically VAVE, it really does help us have the visibility into what our estimated cost is compared to our against our target cost. This presents a pretty interesting challenge in that we're never looking at a single component. It's always multiple. We don't make a component. We make a component to put into an assembly to go into a larger overall assembly that might then make its way into a larger product like a car or an engine, something along those lines. And one component is just a single element of that. So tracking these estimated costs and target costs can generally be pretty time consuming. But what we do have is we have a tool called Cost Insight Reporting that allows us to easily view the requisite data in condensed format. And for those unaware, Cost Insight Reporting is a business intelligence tool that enables our data aggregation and visualization. So through that tool, we can start to get an idea as to where our estimated cost is in relation to our target cost. Now, what you're seeing on the screen right now is a very simplistic breakdown and equation of how one may think of target cost, right? You have your selling price, you subtract your estimated profit, and you ultimately arrive at target cost. However, we want to shift our thinking in a different way to switch target cost and profit around in our equation so that we're subtracting our target cost from our selling price and ultimately arriving at what our profit is. And what this does is it provides incentive for us, an opportunity to expand that profit margin instead of trying to back into our target cost, right? We have our target cost set, we have our selling price set, and the only variable in that equation is what our actual cost of the component is to make, which is what we're trying to measure against in the first place. And furthermore, tracking costs are important to understand what that expected profit margin is, and we want to set ourselves up for success and not failure, whether or not regarding a component is making the company money. So once we have all our target costs set up, identified, and compared against what our estimated costs are currently, we can apply some insightful reporting to the situation to understand where we can start trimming out some of this additional costs. As a result, for those of you who've used a priori, you'll know that a priori generates a significant amount of data as a result of a costing event. And interrogating those parts on an individual basis is really difficult to provide us with actionable decisions regarding design, manufacturability, or otherwise. And furthermore, we can't really scale the analysis ourselves since we do get so much data, and oftentimes, like I previously mentioned, we're looking at a large quantity of parts, not just a single component. So we need to leverage meaningful reporting to allow a more efficient means of digesting the data. And we have a number of out-of-the-box reports and inherent reporting capability that enables this visibility in the costing results. We can either execute watchpoint reports based out of the user interface that are generated and consumed by Excel, or like I previously mentioned, we can employ our Cost Insight Reporting tool to help us get some higher level analytics that enable decision making. So our reports can generally provide many different insights and aid around the conversations around proposed design, justify the change based on tangible data, substantiate claims, and like I just mentioned, justify our decision making on where we want to go from where we're currently at. You know, how do we get our target, how do we get our estimated cost below what our target cost is so that we can see a positive profit margin and really expand on that margin that we might already have. Another analysis path that we might want to take after we've established what our estimated versus our target costs are is which machine is the best machine. And what I mean by that is this is really a methodology for using a priori to find the best machine for a given manufacturing routing. Again, for those of you who have used a priori before in the past, our results only portray the impact of a single machine. It can be pretty time consuming to manually interrogate a costing for each potential machine. And furthermore, we don't really know which machines are feasible, right? We don't want to go ahead and evaluate a costing with a machine that might not be feasible based on size requirements or other physical limitations. And if we don't do this analysis, we definitely miss out on some potential opportunities for cost reduction or assumption of the proper machine. Assuming the wrong machine can be just as disadvantageous as assuming an incorrect cost. We want to make sure that the analysis that we're doing reflects the machines that we have available to us. So what we can do from there is take a look at what machines are available for the particular process within the user interface and see where we're currently at. And then through this evaluation, we can glean a few different results, right? Like I mentioned, feasibility. We can get an understanding of which machines are actually feasible, and this is based on a number of rules that are written within our cost logic to determine what is feasible, what's not. And so, like I said before, the machine selected is not always the lowest cost option. And again, it's dictated based on what the logic and how that's been written in the cost model. But through some creative application in the demo that I'll share later, we can start to understand how we can take advantage of inherent functionality and build a workflow that allows us to compare multiple machines pretty quickly. And the last bit of analysis that I want to talk about before we get into our demonstration here is why bother with manufacturing alternatives? Right, you have a part, you know what the manufacturing routing is intended to be, but we want to explore a bit more. We want to understand exactly, is that the best manufacturing routing? You know, is 3-axis mill, for example, the best routing for our part? Like I just previously mentioned, the manufacturing process chosen, it might not be the most cost effective. And much like the other analyses, it's time consuming to perform a costing for each different routing, compare, and do all the other legwork that's associated with it. So first of all, why bother with manufacturing alternatives? Well, dollars might be left on the table. So this situation provides us with the opportunity to explore other potential possibilities. We don't necessarily know if we're getting the best deal or if we're using the best machine or the best routing. We can understand where that might be by evaluating other alternatives. We can also glean some manufacturability information from the process. To keep with the 3-axis mill example, perhaps we say that a machine is going to be manufactured in a 3-axis mill, but in running through a priori deems that infeasible. Well, that just gave us a pretty good piece of feedback in that we shouldn't even bother considering 3-axis mill as a process from here moving forward. And lastly, the least expensive process may not be the best process. I think this concept can be applied to both manufacturing routing as well as a machine. The best machine, and in this case, the best manufacturing process might not be the one that is least expensive. It depends on your internal availability, if it's internal manufacturing. It depends on your supplier's capabilities. And furthermore, you just want to make sure that you're aligning your assumptions with what you have available for you as far as data is concerned. And at the end of this analysis, what we end up with is a breakdown of which manufacturing alternatives are best, and we can get a comparison accordingly. So now what I'm going to do is I'm going to go ahead and jump into a pre-recorded demo. Like I said, what we're going to be doing is we're going to be reviewing the the topics that I just brought up in context, and that begins with our target cost and comparing that against what our estimated costs are. And from there, we'll get into the other applications that I discussed. And I think what's important to note here is that while we want to start off with the analysis of what our target cost is versus what our estimated cost is, that's our very first step in the process, is understanding where that difference is and which parts exhibit that difference. On top of that, what we also want to do is go through these other evaluation and techniques for trying to drive out costs. But these don't necessarily have to be done in a particular order. I think it really depends on what you're after, part complexity, and if there's opportunity for geometric redesign or changes in how we're assuming the component to be manufactured. So with that said, I'm going to go ahead and jump into my demo. So I'm going to stop sharing my screen right now and pull up a recording. All right. Okay. All right, so you all should now be able to see my recording here. So I will go ahead and get that going. Okay, so like I said before, this demo is going to be primarily concerned with the VAVE workflow that we just previously walked through and the different topics that are associated with it. We're going to first start off with our target cost analysis. We're then going to move into meaningful reports, take a look at machine analysis, and then finally, at the end, we'll talk through manufacturing alternatives. So with that said, we'll go ahead and get this demo started here. So target cost analysis, like I said before, it's a way that we can track a component's estimated cost for their target cost. And again, this is pretty important because we want to understand how we're doing with our costing, right? Now, the first thing that we need to do is we need to first set our target costs. Our estimated costs are by virtue of a priori. But if we go to the cost guide on the left-hand side of the screen, scroll all the way to the bottom, we can see we can set our target cost there, and we can make sure that that's set by seeing that it's checked off. We can also go to the meter at the top of the screen, and you can see that we can also set target cost there. And once we've gone ahead and done that, we can go ahead and click cost. And once our cost is complete, we can go ahead and save our component to make sure our target cost is stuck. Now, part of this analysis relies on us creating rollups, and I've already gone ahead and done so. You can see in the tab to the right of where my mouse currently is, and we'll get there in a moment. But if you hadn't yet created a target cost analysis rollup, you can very easily just go to File, create a new rollup, and supply whatever inputs it asks for you, and then you'll have that accordingly. But if we flip over to the rollup here, I've already gone ahead and specified our target costs on all 5 of these components. So once you have your target cost set, what you're really going to want to do is launch Cost Insight reporting. And again, for those who aren't aware, Cost Insight reporting is just a business intelligence tool that allows us reporting. So when you first get to Cost Insight reporting, you'll be asked to log in, and you'll be presented with this splash screen. Now, before we can start taking a look at our data, we need to export our data from a priori. So we're going to want to go to the Manage tab, and then within there, we're going to want to go to Scenario Export. And we're going to be creating an export set, which is basically just a definition of what and how often of what data we want to export from a priori to this reporting tool. So we'll take a look at this, the one that I've already created. So we'll go ahead and click Edit, and you'll get a dialog window. So you'll have an opportunity to identify a set name, provide a description. It's optional but encouraged. Select our scenario schema, which is just what's in a priori, where we're pulling the data from. Our export scope, we're going to set that as scenario. We're interested in exporting a rollup, so we're going to select as such. We're going to supply our name and scenario name of the rollup, and this has to be verbatim. It is case sensitive, so it needs to be exactly how it appears in a priori. Then we can also set our frequency to once or repeat. And for purpose of this demonstration, I'm only going to be exporting it once, but just know that you could repeat it however often you want, whatever schedule you can create in here. So we'll go ahead and update that. And from here, what we'll do is we'll go ahead and export that data now. And that is what you need to do in order to get the data from a priori to Cost Insight. And from there, once that's completed, we can go ahead and click our Report tab, and that'll launch the Jaspersoft reporting suite. So we'll go to Ad Hoc Views, view our list, and I've already gone ahead and created a target cost variance report that will display our target cost versus our estimated cost and have a bit more information in there. Creation of these reports are really straightforward. You can see that we have a number of data fields that we can drag and drop into the editor there above. And like I said, pretty straightforward. What we're going to do is we're going to toggle between our editor view and our display view. And what that means is it's just going to get us a bit of a better view of the data accordingly. So within this report, we can see that we're presented with a bar graph with a number of individual data points that, again, is comparing our fully burdened cost to our target cost. So in this particular part, you can see that we're $190 above what our target cost is, right? And so with that, we can use that as a starting point to go ahead and start employing some of our other pieces of analysis. So before we move on to the next bit of the demo here, I just want to reinforce that this report is really aimed at making sure that we have a pretty good understanding as to what our fully burdened cost is versus our target cost. So now we have the information from our components, and so now we want to jump into what meaningful reports we can employ to help dig a bit further. So we're going to start again off by where we left off in Cost Insight by looking at our particular components. And we're going to focus on the one on the left here, the 1379344 before DTC. And one other thing before we jump back to a priori is just wanted to make note that you do have the option to zoom in on the data like I just did by clicking and dragging over a selection, just to zoom in if you're interested there. But once we have that all squared away, what we can do now is jump back to a priori to our roll-up that we had before. And like I said, now we have an idea of where to begin our cost reduction efforts, right? We have an idea of where we need to start in a part. So we'll go ahead and open up that part that I previously mentioned. And once the part's open, we can start interrogating in the user interface. But I would hold off on that. I would recommend instead in this workflow that we run a handful or at least one report in particular on a part like this that's complex to see if there's any other information that we might be able to glean that would allow us some more actionable results. So we're going to run the cost driver report. So we're going to go to spreadsheet reports at the top and then spreadsheet reports. Save that report to a location of your choosing, and then generate the report accordingly. So within this report, you can see that we have 3 different categories. We have manufacturing time by process, which breaks things down into their cycle time constituents for the particular part. We have direct costs, which gives us a percentage breakdown of where our cost buckets are. And then we have our manufacturing times for our top 10 geometric features. You can see here we're breaking this down in terms of cycle time from 1 to 10 in terms of most expensive. And CurvedWall 17 is the geometric feature that is most expensive. So now what we do, if we jump back to the UI, what we're going to want to do is we're going to want to interrogate that particular feature, CurvedWall 17. So what we can do in our geometric cost driver panels, we can go to CurvedWalls, we can find CurvedWall 17, we can open it up and we can have a look at where it is in the part. So you can see that's a floor of a pocket right there. And if we open it up, we can see that it's contouring, being assigned to contouring. And what this means is that perhaps we could redesign that feature to not be curved. We could maintain some level of flatness, so we might be able to go in there with facing, for example, instead of contouring, so that we can definitely drive down cycle time. Another thing I want to pay your attention to that we can use within the user interface to help get us some additional results is our heat map. You can see that I've filtered on cycle time just to see where the highest offenders are in terms of cycle time. But from there, we can use our slider here to refine what our color gamut is to better indicate where particular cycle time issues might be. Now, one other tool that I want to bring your attention to is our DTC tab, or Design to Cost. And what this gives us is it highlights potential areas of concern, and in other words, it provides us with visibility into manufacturability issues that we could subsequently rectify, which would most likely yield a cost reduction effort. You can see we have side milling LDD issues, sharp corner issues, and obstructed surface issues. Now, moving on to the machine analysis portion of things. As I mentioned in the presentation, the machine that a priori selects by default isn't always the most appropriate machine. So what we want to do is we want to perform an analysis on machine cost, and that begins with selecting a particular part. That said, what we're going to do is we're going to go ahead and analyze a rather simple part instead of the more complicated part, just in terms of demonstration here. So we're going to go ahead and double click on our part here in the roll-up and open that up in the user interface. And then what we're going to do is start to identify what routing has been pinned, and then after that we'll take a look at what machine has been pinned. So you'll notice that I pinned my routing to 3-axis mill. You can see that by the checkbox to the left there, and you can also see it by opening up the ellipse icon, making sure it's in light blue, and the checkbox is there as well. But now what we want to do is we want to pin the machine as well. So you go in the manufacturing process, you right click on it, go to machine selection, and make sure in this dialog window that the machine has been selected by the user select radio button at the top. So what we can do here is we want to recost the part and subsequently save that part after the costing has been completed. And now what we want to do after that is we want to get into seeing which machines are actually in our digital factory. So we'll go to Tools, VP Toolset, then our VP Manager, and we'll take a look at a priori USA, as that's the VP that we're using. So we'll open that up, we'll expand machining, we'll expand machines, and then we'll select 3-axis mill. And so what this does, it gives us a tabular view of what machines are actually available to us in the current digital factory for analysis. So we'll flip back to the user interface, and we're going to launch our deep costing UI, which is easy enough by going to cost and cost scenario. And so within that, you'll be familiar with this screen if you know bulk costing. What we want to get out of here is just a user input sheet. And we can do that by going to File, Export User Input Spreadsheet. And what that'll do is that'll generate an Excel sheet. We'll save it, and then we'll open it. And we're using this in order to set our machines accordingly for whatever scenarios that we want. So if we scroll all the way over to the right here in our spreadsheet, you'll see that we have 2 columns, one for pin routing and one for a machine. So you can see that we're pinning 3-axis mill as our routing, and we're pinning our machine to virtual 3-axis mill, the small one. So now what we're going to want to do is we're going to jump back to our table that we have for all our machines for 3-axis mill. We're going to copy that table. We're going to paste it onto a new tab, do a bit of data manipulation, and through the power of video editing, we're going to have a bit of a cleaner sheet here. You can see that we have a number of different scenarios that we've created, and the scenario name is indicative of the machine that we're using in the analysis. And if we scroll all the way over to the right again, what we can see is that we have our pin routing in column Y, and then in column AB, we have our machines. And so once we have this saved and complete, we're going to go back to our UI, and we're going to launch bulk costing. So we're going to do that by going to Tools, Bulk Costing and Analysis. And that'll generate this UI here. And we're going to select our new bulk cost group icon. So once that icon is up and the dialog window rendered, you're going to want to type in a name for your set. You're going to want to point to the directory where your components are located. And you're going to want to point to the input sheet that we've had just created. So now from here, you'll want to select the Only Cost Components in Spreadsheet button. If you don't do this, what will end up happening is Operator will cost through all your components that are in that directory, including the ones that are in the spreadsheet. And you're also going to want to specify a roll-up name. If you don't specify a roll-up name, what's going to happen is after completion of the costing, Opera will not generate a roll-up, and instead the components will just be free-form in the database, and you'd have to search and aggregate that roll-up yourself. So with all of our inputs set, we'll go ahead and click OK, and now you can see that we're presented with a tabular view of all our different scenarios that we're going to be costing through. I'd recommend just doing a quick spot check to make sure that everything looks appropriate, that you have your appropriate number of scenarios in there, all of your high-level inputs are set appropriately. And once you've done that, you can go ahead and click cost. This is just a message stating that one of the parts in your set already exists within the database, and it's just asking if you want to override, and use your best judgment there, but I just did so for sake of demonstration. So after costing is complete, and like I said, if you specified, you go back to the UI and the roll-up with those parts will automatically open. Once the roll-up has completed loading and any parts that have not completed costing been interrogated, what we're going to want to do is we're going to want to run a spreadsheet report. So we can go to reports, spreadsheet reports, and then we're going to select our roll-up summary report. And within that, what we're going to do is we're just going to save that and then have a brief look at the results. So we'll let that open. And so what we want to do is we can see we have a line item for every single discrete process, and within that we want to focus on our fully burdened cost to see which machine is the least expensive, and if we're looking at a machine that is of interest, what the price of that is. Now lastly, we're going to talk about manufacturing alternatives. Like I mentioned before, manufacturing alternatives can be important levers to pull when we're looking to see what where we have opportunity for cost reduction. In this example, we're going to go through alternatives for 3-axis mill, 5-axis mill, and sheet metal, and you can see that I've already specified my 3-axis mill scenario and done the costing for it. So what we're going to want to do is we're going to want to go ahead and create a new scenario for 5-axis mill by going to Scenario, Save As, calling it what you want. I'm going to call it 5 a.m. and adding a description if applicable. Now, as part of this, a new scenario is going to be generated, but it's going to have the same parameters as previous. So what we're going to do, we're going to want to go ahead and remove any overrides that we made during costing. 3-axis mill overrides aren't applicable anymore for 5-axis mill. We're going to want to go ahead and pin our 5-axis mill routing. Again, you can see the checkbox to the left of that. And then we're just going to go ahead and click cost. So we'll go ahead and let that cost. Once the costing is complete, obviously you're going to want to go ahead and just save the scenario. And now what we're going to do here is we're going to create a new scenario for sheet metal. Same process as before. We're going to go to Scenario, Save As. We'll call this one sheet metal. Again, description if applicable, but encouraged. And we'll go ahead and create that scenario. So once that scenario is created, we're going to go ahead and remove all our overrides again. But before we do that, we'll go ahead and change our process group to sheet metal. And notice when I remove the overrides here, our process group goes back to stock machining. Just pay special attention when you're doing that to make sure that your other overrides haven't been accidentally overridden. So now that our costing is complete there, we're going to go back to our original scenario for 3-axis mill, which is going to be our base scenario. And we're going to launch our comparison from here by clicking the comparison button that's to the right of the cost icon. And that's going to present us with the dialog window to enter the name of the comparison, a scenario name, and a description. In this case, I definitely think something meaningful in the description is very helpful. And then from there, it's going to ask you to select the particular scenarios that you want to include in the comparison. And you do have the option to multi-select by control left click. Make your selection, click OK, and then what you're going to be presented with is a comparison. And from here, you can add, remove, open, change your base scenario, whatever you might want. But what we're interested at this point is running a cost comparison report to see what the difference in breakdown is, and so that we have an offline version of this analysis. So what we're going to do from there is going to go to Reports, Spreadsheet Reports. We're going to select our cost comparison report, and we're going to save it to a particular location that we're interested in. We'll let our report generate. And from here, we can start to see what the difference in costs are, some other high-level information, and start to get an idea as to which manufacturing routing that we want to pursue further. And ultimately, like I said, take this offline gives us an opportunity to view this analysis without having a priori open. So that concludes our demo. What I'm going to do now is I'm just going to jump back to our presentation. So just give me a moment to do that. I'm going to go ahead and stop sharing my screen once again. Let me go ahead and share my presentation. Okay. So in conclusion, and wrapping up our presentation here, couple points that I want to hit on and that I just want to reiterate here. We're in the midst of a global pandemic right now, and that being said, a lot of companies are being forced to postpone any NPI. Really, the onus has been put on our value engineering and value analysis groups to understand where we can drive cost out of our components and products that are already existing. And like I said before, it's really difficult to understand where the cost can be driven out of these products, as well as just the general ability to prioritize based on what their respective cost impact is. If we don't employ these particular analyses or a form of them, we run the risk of missing potential opportunity to improve our margins. And through a priori, we can really facilitate this manufacturing cost analysis that'll help us identify what those opportunities are. So if there's anything in this particular presentation that resonated with you, feel free to reach out to either myself, your customer success manager, or your expert services consultant, if applicable, and then review the materials on our support site that will be included in a link following. And hopefully this presentation has provided folks with some inspiration on how to substantiate cost-saving initiatives in leveraging a priori. And really, it starts with identification of cost-saving opportunities. So I just want to say thank you very much for joining this session and listening to this presentation and live demo. My email is on this slide and the link to our support site as well. So if you, like I said, have questions hereafter, please feel free to reach out or go to our support site for more information, documentation, and other material. Now that said, Amanda, are there any questions from the group in the chat?
So not at this point, but I'll give people a few moments to enter questions. One question that came up for me, Matt, as I was kind of watching your presentation is, where have you seen dramatic cost savings for customers in using this type of technique?
Yeah, so that's a great question, Amanda. So where I've seen it most applicable is like my presentation suggested in the VA/VE space, where customers are really trying to understand where they can lean out their product, right? Perhaps they feel as though there are particular pieces of geometry that could be redesigned, but I think where the most impact could be had is at that stage where you're trying to investigate where you can reduce your costs, and either through design alternatives, manufacturing alternatives, or otherwise.
Okay, great. So I'm not seeing any other questions come in at this moment. So I think we might be done here, Matt.
Okay. All right. Very good. Well, thank you everybody again for joining the session. I really appreciate your time.